Hey, this is Mr. Chernetsky, and this is Geometry Unit 1, Lesson 4. So, in this jump start, they're going to have us draw a picture based on the mathematical description of the vocabulary term. So, the first one they start out is a circle, which they're defining as the set of all points in a plane that are equidistant from a fixed point, called the center of the circle. So, if I'm going to draw this, really what we have here is we'll start with our center point, and then I might have another point out here that is some fixed distance. Do a little bit better job. Okay, and then I have another point that is going to be that same distance away. Just estimating here. And I'm going to mark those as being the same. And I have another point that's going to be the same distance away. And I make another point over here. And all of these, as we start to build more and more points of the same distance from our center, if we keep filling in those points over and over and over again, an infinite number of times, we will eventually form a circle, and that is a mathematical definition. An angle they define as the union of two rays that share a common endpoint. So if we have a common endpoint here, and we have one ray going out like this, going on and on forever in one direction, and another ray like that, that was what we can define as an angle. An angle of rotation is going to define a certain amount of turn based on the number of degrees. So we do say that going counterclockwise is the default positive motion. So I could take, for example, a 90-degree rotation. Well, here's my 90-degree angle. And we would default positive going counterclockwise. So, okay. And that would tell us how far to turn. Okay. We are talking about degrees, but the question is, what is a degree? And why do we use it? Well, a degree we can define as being 1/300th. Actually, I'll just write it. A degree is 1/360th of a circle. Okay. In other words, we divide a full circle in 360 degrees, and there's different theories why we did that. Some theorize that that is close to being the number of days in a year, and people thought that was a good reference to a circle. And 360 is a good number because we can divide 360 in lots of different ways. So it ends up being useful for us. Okay. On the next pages here, we have some ideas that are about like some of the descriptions in the words that we've been using for our transformation. So for example, we've been using slide, flip, and turn when we're talking about translations, reflections, and rotations. And some of these are misleading, and some of them just don't give us enough information. So when we're talking about a slide as a translation, that's not good enough. We need to know how far are we moving and in what direction. Also, when we say turn, we need to know, well, how far, and what are we turning around? What point are we turning around, and how many degrees? So we need to be very specific when we're talking about a transformation. for another example, the word flip, it's a kind of a bad way of thinking of transformations, especially in terms of a reflection. It is how we use patty paper, but it doesn't really accurately describe what's happening in real life or mathematically. So you can think of a playing card, and if we say to flip the card over, we get these two sides after we flip, and that is not a reflection. That is a flipped card. If we had a true reflection, we would see a mirror image of the card, but that is not the case. So we want to avoid using flip, turn, and slide. They're not very mathematical words, and they're not good enough for us to describe what's going on in transformation. In the next few pages here, we have an opportunity for you to use your words and images and go through kind of like the editing process here, which is what we did in class, with the ultimate conclusion of coming up with these mathematical definitions. So a translation is a set of points in the plane that move the points at the same distance and direction along lines that are parallel to each other. So when we translate something, like say I've got some segment here, okay? If we translate it, they're all going to move the same distance and direction, which is why afterwards we end up with the same shape and the same orientation. If we go to a rotation moves points in the same direction along concentric circles through the same angle of rotation. So if I have something that is being rotated, like some segment, like, again, maybe we'll do AB, and we're going to rotate around some center point. Maybe this is my center point here, okay, and that's the point we're going to rotate around. We would rotate in concentric circles. That's the path that A would move along, and B would move in a bigger circle centered around the same point. And maybe we rotated like 90 degrees, okay? So this angle that we rotated, that's our angle of rotation. Going counterclockwise. And that's what our shape would end up moving along those lines. So that is a visual of our rotation here, okay? Each point moves along in its own circle. Okay. A reflection. Move points across a specified line of reflection so that the line of reflection is the perpendicular bisector of each line segment connecting the corresponding pre-image and image points. Okay, so we introduced there's a lot here, but the key term, new term that we're introducing is this idea of a perpendicular bisector as describing our line of reflection. So if I've got, we'll do our line segment again here. So here's A and B, and maybe our line of reflection is going something like that. And we reflect along that line. Our line, each point is going to reflect and be perpendicular to, I need to redo that. That's not quite perpendicular. Let's see if I can do that. There we go. Okay. And do the same thing for A. Nice and perpendicular. Something like that. Okay, so this line reflection is going to be perpendicular, so there's the perpendicular part, and it's going to be a bisector between B and B prime. In other words, it's going to split those two, or split that line in half. And that assures that both points are equidistant from our line of reflection. Okay, so those are proper descriptions of what a translation, a rotation, and a reflection does. Translations, rotations, and reflections are rigid transformations because all angles and segments are preserved. In other words, shapes do not change in size, or they don't change shape. So that is going to be important. Our takeaways, this is just the same thing that we wrote for our translations, rotations, and reflections. Okay, just putting them back in one spot here. So to summarize, we're not really going to use slide, turn, or flip. We're going to be very careful about our descriptions of transformations. Okay, let's go to our retrieval. We're going to be getting into quadrilaterals in this next set of lessons. So we need to practice with what some of our quadrilaterals are. So a quadrilateral being a figure with four sides. A quadrilateral with four congruent sides. Well, most people would think of a square. See if it'll automatically draw that for me. Perhaps not. There we go. So a square. But we could also have something that's kind of like a tilted square. There we go. Where all the sides are equal. And this is called a rhombus. A quadrilateral with four congruent angles. There's two possibilities. We could do a square again. Where all of our angles are 90. But the thing that also works is a rectangle. And those are the two that could be quadrilateral with four congruent angles. A quadrilateral with opposite sides parallel. Well, again, a square works. See if it'll draw a square. There we go. So the opposite sides are parallel to each other. A rectangle works. So again, the opposite sides are going to be parallel to each other. A rhombus also has parallel sides. And all of these fall under a bigger category of quadrilaterals, which we call parallelograms. And those are the 4 that would work there. Okay, that's the end of this lesson.